deals with sea levels, water levels, and discharges of rivers, intensity, duration, frequency curves, flood frequency analysis, low impact development, and urban drainage, and that were the subjects I covered. What I wanted to do with those comparisons, I wanted at the same time give detailed impact into methodologies, and at the same time broader overview of some steps in those methodologies. And I wanted to make comparisons which provide enough information so I can use it as a foundation for writing of articles. And that was, how to say, the main idea which was always driving me through these comparisons. I wanted at the same time to show enough knowledge so someone who has to deal with the subject maybe for the first time that can understand something, but at the same time to give broader overview so someone who knows the subject can see some information about subject and can provide some conclusions related to that. Beside those hydro-environmental, I say variables like sea levels, water levels, and etc. Most of my comparisons were related to machine learning, and most of them cover prediction with machine learning models. So I made a table which covers my 12 comparisons and covers and shows which variables were used in each comparison, and that means here where you can see ML, for example, that means that comparison covers machine learning. Where you can see IDF, that means that it covers intensity, duration, frequency curves. Where you can see LID, it covers low impact development practices. When you can see F, it covers flood frequency analysis, but somehow all of those comparisons are, for example, related to flood in some way. Some maybe with a larger extension, how to say it, and some in maybe smaller extension. And what I wanted to do, I already said that the main idea is to make a foundation for articles, for writing, but also this second idea, which I already mentioned, is to give review, how to say it, readable by people who has to introduce them to subject, and the second to give broader overview of methods and steps in methodologies covered in those comparisons. And so you can see at the left side that, for example, the first 6 comparisons and the 8 comparisons covers this, how to say it, more human readable manner, and that 7th comparisons and the last 4 comparisons covers this more in a machine readable manner. That's what I wanted to say. Here I just links. What I wanted to say, for example, on the left side, you can see example of this descriptive comparison, and on the right side, the example of this quantitative comparison. And you can see that there are some difference on the right side for those overviews, or how to say it, quantitative comparison, just to make it simpler. I tend to uh, choose most important properties and specify if they were covered in some papers or not. On the left side, where it is like a descriptive comparison, I tend to describe all of those properties, more important and less important. And I found it very convenient. This, how to say it, these Boolean operators, true and false, because I think they can be really good for visualizations and to prove a point when you are writing some article or just making some comparisons. Because then you can say it in 7 of 20 papers, this performance matrix was used or it was not used. And I think it can be very interesting for scientific articles. Okay, I could maybe enter some of comparisons, but maybe even better would be if I enter this review I made several days before. I made a review of application of machine learning models for prediction of variables in hydro environment, and in that review I covered sea levels, water levels, discharges, and their prediction by machine learning. And that is why I say hydro-environmental variables. And okay, this works. Can you see the review?
Yes.
Okay. I found it very convenient and useful to make the review in the way as it is, and I tend to make a review in a way that at the one section I put all of those more descriptive, those they cover the same methodology or have very similar methodological steps in it. But different variables are predicted. And in this another section, I put 3 comparisons which deals with overview of some important steps in researches, just to make a good point when writing an article and to easily show that there are some things in some papers, there are some things which are maybe not enough covered, and etc. Okay. And just to shortly conclude, this structured and visualized collection of knowledge is very important for science. And what I can say and what I see from most of the papers in last years, maybe last 5, 6, or 10 years, that most of them are most of them deal with some methods or models or some hybrids of methods, but very few of them deal with review or with systematization of knowledge. And that is, I think, the key point where ORKG has its main power, because one of the definition of science that it is collected and systematized knowledge. I tried to find who the author of this citation is, but I could not. But it is indeed, it is really the truth, and we cannot deal with science if we do not collect and systematize knowledge. And I think that ORKG represents a useful tool for that purpose. Of course, there are some maybe positive sides and some negative sides, but the positive sides definitely are much stronger than than these negative sides. For example, I could name maybe one drawback. For example, I don't know why it is made like that when you publish comparisons and you are the author, maybe you are the only author, you cannot make any modifications in this first version it is which is published. I think maybe there should be some time schedule to at least maybe make some modification in next 2 or 3 days, because mistakes happen when you work. You always make some mistake, and I think it would be a good thing to maybe uh, make it different. But all of the other things I think are quite positive. And I want to thank you all for listening to me and for working with me, cooperate, and thank you. That's all.